A cursor is a pointer into a set of records. It can be defined using select statements. For example, we can define a cursor named transCursor that operates over the set of rows indicated by the following select statement. First, we declare the cursor, then we will indicate the row. Declare a cursor that's called transCursor as, and that's the statement, declare a cursor transCursor as, and then select asterisk from transaction where purchase price is greater than 10,000. And that's our code for the cursor. So after an application program opens, a cursor can be placed somewhere in the result set. A transaction can open several cursors, either sequentially or simultaneously. The problem that those cursors requires considerable amount of memory. To solve that, we can define reduced capability cursors and use them when a full capability cursor is not needed. There are 4 cursor types. Forward only, where the application can only move forward through the record set, or scrollable cursor, where the application can scroll either forward or backward through the record set. Under, which has 3 types of static, the key set and the dynamic. So the 3 types are the static, the key set, and the dynamic. The static cursor processes a snapshot of the relation that was taken when it's opened. The dynamic is a fully featured cursor where all inserts, updates, deletions, and changes in row order are visible. The keyset cursor combines features from both static and dynamic. Choosing the proper isolation level and cursor type is very important in the database stage. One of the main problems that happens in a multi-user database is controlling and ensuring security. During database construction, a list of all database users should be developed, including the level of authorization they should have, and this should be documented at the beginning. You should know exactly how many users do you have, who are the users, and what level of authorization do they have. The level of authorization can be determined based on user responsibility. In the implementation phase, we can enforce the security requirements through database management system and other applications. The purpose of that is to limit the actions of a user based on his or her role in accessing the database. One of the common systems used to control user authorization is the username and password, or what we call the login system. This figure shows an example of the level of security that can be given to a certain person. So for example here, James as a shop manager will be able to alter all tables, while Richard as an accountant can update customer table only. Although you have a login system, you have to keep your database behind a firewall with putting the possibility of a firewall breach. You have to update your operating system and database management using the latest service packs and fixes. You have to use the least functionality in a network or operating system. Don't open many ports on the server and support fewer network protocols such as TCP/IP. Disable guest accounts or any other default accounts. and never allow all users to access the database interactively unless it's necessary. Usually, the database server is not used by normal users and it's been secured behind locked doors with very, very limited access. When creating accounts, use passwords with combination of numbers and letters. Monitor the login or the log file for attempts to break into the system. Frequently check groups and role memberships and assign the lowest privilege possible, limited database administrator account privilege. Develop a security plan for an emergency or any emergency that might happen, and you can even create like a test procedure to make sure that the plan works. In addition to the database management system security, you can add a code in the application program as an additional security level. It is better to start with your database management system security features, which are faster, cheaper, and probably result in higher quality results than developing your own. You can add application security only if needed. When a data entered by a user to modify SQL statement, it's called SQL or SQL Injection Attack. The code should be reviewed and edited in case to ensure that no additional SQL syntax has been entered. For example, adding the syntax or true at the end of the SQL statement where employee name equal to Benjamin Franklin made it return all rows in the table. In case that someone did get to the database or to the server physically failed, the database must be restored as soon as possible. The process of restoring the database is called database recovery, which will either recover the data through reprocessing or through rollback, rollforward method. In the recovery through reprocessing, the database can go back to a point where it was saved and reprocesses the workload from there, but this technique is not recommended. The reason for that, the system will never catch up with the schedule or might cause different results. In the rollback roll forward, it's periodically saved and a database login is kept to track the changes from every save. When there is a failure, either we roll back to undo all the changes that caused the system failure, or roll forward, which replaces a corrupted transaction with one working that's been saved before. This figure shows the rollback process and undo process that will return the database to what it was before the change. This figure shows the roll forward, where a redo process will provide the records of the database after changes. A checkpoint can be done several times to synchronize the database with the transaction log, which will speed up the recovery process in case of any system failure. Most database management system products automatically checkpoint themselves. During the execution, a failure happened, but you can see that we have a log record that was written at that point. The system will correct itself with checkpoint and delete the whole transaction. So from the previous slide, we can summarize database administrator responsibilities as generating database application performance reports, investigating user performance compliance, assessing the need for changes in database structure or application design, modifying database structure, evaluating and implementing new database management system features, and tuning the database management system. And this is for any database management system. They have to do the same and search for the updates and make sure that everything is up to date, have a backup for the system and all the other important things that's related to the database, including security. Database administrator is responsible for maintaining the database repository. Database repositories are collections of metadata about users, databases, and its applications. The repository may be virtual, as it is composed of metadata from many different sources, or an integrated product from a case tool vendor or from other companies. The best repositories are active and they are part of the system development process. That will be all about database multi-user database management. And if you have any questions, you can either email it, or you can call me, or you can Skype with me to address these issues. Thank you and have a great day.